Welcome back to Basic Mathematics. In this video, we're going to be looking at writing percent problems, taking situations described in real-world terms, turning them into percent problems so that we can solve from there. So without further ado, let me get my head out of the way and let's dive right in. In the past 5 years, you have noticed that only 75% of the seats in your classrooms are being filled. If there were 48 students in a class 5 years ago, how many students are in class now? And the big idea of percent problems and writing percent problems is to take this paragraph of text and turn it into something very straightforward. I might think of something like now has 75% of before. Right? Your classes today have 75% of the students your classes had 5 years ago. And thinking about things like that, we realize that the number of students in the class now is the unknown, and the class 5 years ago, in this case, was 48. So how many students is 75% of 48? Turning that into a percent equation, x equals 0.75 times 48. For the sake of time, I'm not going to go off to the side to perform that calculation. You might remember that 75% is 3/4. A quarter of 48 is 12, and 3 times 12 is 36. So x equals 36. And since this is a question given in paragraph form, I'll give an answer in paragraph form. There are 36 students in a class now. When it comes to talking about percents, instead of giving a percent directly, very often you'll see it described as a percent change. Right? That's either a percent increase or a percent decrease. The most important thing to pay attention to with percent increase and percent decrease is that even though they feel like opposite, right? Increase and decrease are opposite of each other. Percent increase and percent decrease are really unrelated as far as the calculation goes. And as far as performing the calculation, it's a matter of remembering, what does percent mean? Remember, percents look like numbers, but they are not numbers. So if I want to know what is 60 increased by 20%, that has to be 20% of something. And that something we implicitly assume is the thing we started with. So you can fill in the blank and realize that this problem is asking, what is 60 increased by 20% of 60? From there, writing it as an equation. What? I don't know. I'll call it x is equal sign 60 increased by. That's a phrase that tells me we're going to add. 20% is 0.2, of is multiply, 60 is still 60. Then performing this in 2 steps. 0.2 times 60 is 12, and 60 plus 12 is 72. So if we start with 60 and we increase by 20%, we get to 72. What would happen if we started at 72 and decreased by 20%? Once again, the key here is to remember that percent always has to be of something, and that something is always assumed to be the thing you started with. That is poor design of the English language, but it's common phrasing and something that you have to become familiar with. So what? I don't know. Is means equal sign. 72 is still 72. Decreased by is phrasing that tells us to subtract. 20% as a decimal is 0.2. Of means multiply. 72 is 72. All right, coming off to the side, 72 times 0.2 is 14.4. So we're looking here at 72 minus 14.4. We can fill in a decimal point and a 0 at the end so we can perform the calculation. Right, 10 minus 4 is 6, 11 minus 4 is 7, 6 minus 1 is 5. Drop down the decimal point. And that's what I meant when I started this off. If you start with 60 and increase by 20%, you end up at 72. If you start at 72 and decrease by 20%, you end up not back at 60, but all the way down to 57.6. So pay attention and be careful. Percent increase and percent decrease are not opposites of each other, and you have to be sure of what you are doing. In this course, I want to take a look at 4 specific applications of percent: markup, discount, sales tax, and commission. All 4 of these show up in the realm of shopping. Some of you may be employed on commission and be very familiar with how that works. Everyone should be familiar with the idea of discount and sales tax. If a object is sold at discount, you'll pay, excuse me. If an object is sold at discount, you'll pay less for it than the sticker says, and understanding how much less is an important tool. And sales tax is applied on most items, and you'll pay more for it than what the sticker says, because you'll also have to pay the state for the right to purchase the item in the first place. Markup is not all that common unless you are familiar with the back end of running a store, but markup is how stores themselves make money. A store purchases items at a wholesale price and then increases that price by some amount called the markup rate in order to sell it at a higher price, have a margin to allow for discounts, have a way to pay the employees and pay the rent of the store, and have a little bit of a buffer so that you can absorb the cost of things that don't sell. When you see these phrases in a problem, you should replace them mentally with percent increase, percent decrease, or percent of as appropriate. So a thingamawhatsit usually costs $250. Currently, all thingamawhatsits are on sale at 10% off. How much will it cost now that you have the 10% off discount? Remember, sales price discount is a percent decrease. So this problem is asking us to consider 250 decreased by 10%. And the thing to remember about percent is that it's always percent of something, and that something is always where you started. So 10% of 250. 250 minus 0.1 times 250. 0.1 times 250 is 25, and 250 minus 25 is 225. You can buy a thingamawhatsit for $225. So that's the basic idea of percent change, and the applications that percents come up in. Certainly, there are far more applications, far more places where you see percent in the world than the things we've talked about today, but that should give you a feeling for how the idea of percent should work. Take a look at the practice problems involving percent and problem solving with percent. See where you can get to with that, and I'll see you next time.